Hello, Legacy students. Welcome back to watching videos. Today we're going to look at section 4.1, which is on using graphs to relate to quantities. So what you're going to want to have on you is your notebook and also a pencil. You're not going to need a calculator today. So this video is going to focus on how to identify variable quantities when we're given a graph, how to describe relationships, and also sketching a graph based on a real life or contextual problem. So the first kind of problems we're going to look at is they're going to give us a graph, and then we need to figure out what are my variables and describe what are the variables doing as they're related at various points. So in this one, they say the graph shows the volume of air in a balloon as you blow it up until it pops. What are the variables, and describe how the variables are related at various points on the graph. So my variables, if you guys remember, on a chart right here, this is the title of my chart. So this isn't one of my variables. The variables are always going to be the labels of my axes. So one of my variables is time, and the other one is volume. So time and volume are my two variables. And you're going to want to sketch this graph a little bit on your notebook. So now I need to describe the variables. So it looks like my graph goes up, and then it kind of stays constant for a little bit. So it doesn't like go up or down, it just stays in a straight line. Then it looks like it's going up again, and then goes constant, and then goes up again, and then constant, and then up again, and then straight down. So I can kind of think of this, it's as I'm blowing up a balloon. So right here, where it's going up, this must be where I'm blowing air in. Right? So every time I see a straight up curve, right here, and right there, just a tiny bit, that's where I'm blowing air into my balloon. Now, when I have this straight lines, I'm not putting any air in the balloon right there. So that must be when I am breathing, right? I gotta breathe to put air in the balloon. So it's there, there, and there. But now this sharp decline that we have right here, and that's when they say it pops. So that's where the air, the volume of my balloon goes straight down. So this is where, or actually right here on this tip top, that's where my balloon pops. So now one question I'm going to ask myself is, how many times do I actually breathe? So how many times am I actually blowing into this balloon? So let's count. I'm blowing air in right here. 1. It's my first time blowing air in. Right here I'm blowing air in. Blowing air some in here. And slightly a bit right here. So I'm actually blowing air into my balloon 4 different times. And that's how you describe how variables are related. Basically, you're saying, as I blow air in, my volume is going, or as I blow air in, my volume goes up, and then it pops at the end. So let's look at this one. I have variables in each graph, so I need to find my variables. Now, if you remember, it's always going to be your axes. So I got length for one variable, and time for another variable. So those are my two variables for this guy, length and time. Now, if I look at my title right here, this is always my title, and I have board length. So it looks like as my time goes on, my board's length is getting smaller, right? So it looks like at these points right here where I'm kind of putting my arrows, something happens to my board. Most likely it's getting cut or sawed off. So what I could say, I could put the length of the board gets cut. Looks like it's 1, 2, 3 times. and it gets shorter each time. Just to give me basically a description of what's going on. That's what I'm trying to do. I'm trying to make sense of the graph and understand why does the graph look the way it does. Now, the next couple of problems, they're going to give you a few kinds of graphs, and they're going to say which graph could represent the data. So the best way to start these problems is to look at the change on the chart they give you. So if I look up here, it looks like I'm adding 1 each time. Then I got to look over here. Let's see what's the difference between there and there. So I did it on my calculator, and I got that I added 665. Then I'm going to see how much I added here, and that was 2,444 new downloads, because we're talking about a band allowing someone to download new videos. Next one, that's a really big jump. That is 6,971 downloads. Change. So now, first things first, I'm going to look at my different graphs. I'm going to do kind of process of elimination. First of all, I notice my downloads are going up. My numbers are always going, I'm getting bigger numbers each day. So I can't have D. D is going down. Can't have that. That doesn't happen. So I either have B, A, or C. Now, if we look here, I can't have A. Because if you look here, see how this is not perfect? It's not the same number every time. This one right here, it looks like it's like a perfect increase. It has a perfect increase between here. It looks like it's the same distance there and about the same distance there. So I can't have A. This doesn't have the same distance each time. So it's either going to be B or C. Now, if I look here, C, it looks like it kind of levels off. You kind of like trace the curve. If I kind of draw through here. See how it kind of like almost levels off? That's not what's happening here. I keep on increasing, and assuming this pattern continues, I would get probably into the 20,000s. So it can't be C because I'm not leveling off. So process of elimination, it's got to be B. That's my graph. Let's look at one more like this. The table shows the amount of sunscreen left in a can based on the number of times the sunscreen has been used. Which graph could represent the data shown in the table? So, just like last time, I'm going to find the difference between each of these. So I have 0 to 1, that looks like it's plus 1, and then also another plus 1. Right here, if I subtract those two, I get 0.2 change, and it's actually a negative 0.2. Right here is another negative 0.2. And another negative 0.2. So it looks like every time I use this sunscreen, I'm actually using 0.2 ounces. So we need to figure out which graph could represent the data. Now, if you look here, it goes down by a constant amount. So it can't really be B, because if you notice right here, I have this really big gap between A and B. So that's kind of losing a few uses, because there's probably 1 use here and 2 uses here. So it can't be B. That's a really big gap in my X values, or in my number of use values. Now let's look at the other ones. I have A. It looks like at 0 uses, I have 5 ounces. Now this is a really big gap, but let's keep continuing. 3, 2 uses, and then at 3 uses, because this is 3 uses, right? They're saying I have 0 amount of sunscreen. Well, that's not the case. I still have 4.4 ounces left, so it can't be A. Then if I look here at C, it looks like it actually goes down, if you notice, by a perfect amount each time. So it's got to be C for an answer. The last problem today. A model rocket rises quickly and then slows to a stop as its fuel burns out. It begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. What sketch of graph could represent the height of the rocket during its flight? So I'm going to start my sketch. I'm going to start my graph. So I'm going to put an axes here. Now I got to label these axes. So they want to know about the height of my rocket. Then I'm going to look at the time, because that's kind of what measures my height, depending on what height I have. Because if it's 0 minutes, if I haven't even lit my rocket, I'm going to have 0 height. So we're going to start right here at 0, 0. Now they say it quickly rises, so I'm going to make this quickly rise. And then it says, oh, the fuel starts to burn, it burns out, oh, it's quickly falling, and then they say, oh, but the parachute opens. So that's when I can go and make a gentle fall to the earth. Make it a little slow. So now I'm going to label my sections. So right here, this was where my rocket rises quickly. About right here, it begins to fall. Then right here, right where we hit that change in my line, if you notice how my line became a little less steep, this is where my parachute opened. And now it's going to start falling slowly. Now where it hits right here, that's where my rocket hit the ground. Basically, as long as you can give me a graph that looks kind of like you have the right idea, you basically can say you have the right answer. And you label it correctly. Now, if I would have put like a line that goes like right all the way up, that would have been very well, because it shouldn't rise that fast. Like if you go a straight up line, that's not going to be very good. But I always kind of need to give myself little curves. So, that's all, folks. See you later, Legacy.